Bismillahir Rahmanir Rahim. Let's look at TCP, Transmission Control Protocol. Unlike UDP, TCP is connection-oriented and reliable. Connection-oriented meaning before a sender and a receiver, before there's any transmission between a sender and a receiver, both sides establish a connection, and then after the connection is established, they send packets to one another, packets that have unique sequence numbers, and every packet will be acknowledged. So this makes the transfer reliable. After completion of the data transfer, the connection is terminated. So unlike UDP, in UDP, if you want to send something, you just send it. But in TCP, it's different. You establish a connection, and then the two sides decide on the parameters, the speed, things like that, and then the actual transmission of data takes place. And then after the data transmission is finished, it's not ending there, right? You have to go and also end the connection properly, and then it's over. So this is why in TCP we have connection establishment, we have data transfer, and we have connection teardown phases. Okay, we have 3 phases. And this is the main characteristic of TCP. We have to go through these phases. So once again, TCP enables process-to-process communication. So we go from one application process on the sender to another application process on the receiver, and we differentiate the packets using port numbers. So every application will have a unique port number. We have stream delivery services. We can deliver packets from the source to the destination in the form of a steady stream of bytes. Okay, a simple steady stream of bytes. We can do that. Full duplex communication, which means both the sender and receiver can send and receive at the same time. Connection-oriented services, as I explained earlier, there has to be a connection established first. And reliable services, meaning we have acknowledgements for every packet that was transmitted. And we also have sequence numbers for packets to make sure that when they arrive at the destination, they are placed in the right order. So because of these features of TCP, congestion control, error control, flow control, reliable delivery of packets, it gives the impression that there is a dedicated connection between the two sides. But in reality, there isn't a dedicated connection. We actually are transmitting on between these various routers, right? But the way TCP is designed, it gives the impression that there is a dedicated connection. Now we have buffers at both sides. Okay, we have sending buffers and we have receiving buffers. And these buffers play a very important role in the success of the reliable delivery mechanism in TCP. So on the sending side, we have this buffer. Each space indicates a byte. Okay? Each free space here is 1 byte. The white spaces are empty. So the sending process, when it wants to send information, it will load it in the empty spaces in the buffer. And this will be the next byte it will write. The green spaces are bytes the process has written, but they have not been sent yet, right? We have written them in the buffer. They are waiting to be sent. They have not been sent yet. And we have these blue ones. They have been sent, right? They have been sent over to the destination. So why are they still sitting there in the buffer? It's because we have not yet received an acknowledgement for these processes, for these packets, these bytes. When we receive positive acknowledgements for these packets, for these bytes, when we receive positive acknowledgements for these bytes, they will be removed from the buffer and we will get these white empty spaces again. On the receiving side, we have the buffer as well. Now, in this case, we have two types of spaces. We have the white spaces like the sending buffer, which are empty. Packets that arrive from the sender get stored in the buffer. Okay, the bytes, they get stored in the buffer. So these blue ones have been received. Okay, so what are these blue ones? You have to understand, they have been received. Okay, they have also been acknowledged. Right? They've been received and they've been acknowledged. So what are they still doing in this buffer? They are waiting for the receiving process to pull them up. Until the receiving process does not take these bytes up, they will remain there in the buffer. So your buffer space will not be free. Even after we have received the packet successfully and we have sent the acknowledgement, we cannot remove these packets because they have nowhere to go. Unless their application process calls them up, they have nowhere to go. So they're waiting. So as soon as the application process calls them up, these bytes will become free.